Hello everyone. In today's video we'll be synthesizing phenol from aniline via a diazonium salt. This reaction uses strong acids and high temperatures. Also, phenol is poisonous and aniline is carcinogenic, so be sure to wash your hands and wear all proper lab safety gear. Be sure to perform this reaction outside or in a fume hood as gases are evolved. To begin, measure out 27.5 milliliters of concentrated sulfuric acid and 24 milliliters of aniline. On a stir plate, place a beaker with 150 milliliters of distilled water and start it stirring. Now, slowly start to add the sulfuric acid. Adding the sulfuric acid is very exothermic, so be aware that the water will be very hot. This is intended. Next, very slowly add the aniline. A reaction will take place and aniline sulfate will form. The heat generation from the addition of the acid should be enough to dissolve the sulfate. If not, turn on the hot plate and gently heat the solution until it does all dissolve. This can take several minutes. After it's all dissolved, remove the beaker from the stir plate and replace it with a large Erlenmeyer flask with 200 milliliters of water in it. Now pour the aniline sulfate solution into the flask. Now take the Erlenmeyer flask and place it in a large ice bath. Place a stir bar in the flask and begin stirring the solution. While the aniline sulfate cools down, we can make up a sodium nitrite solution. Place 50 milliliters of distilled water in a small beaker. Now, add to that 20 grams of sodium nitrite and start stirring. It may take a few minutes, but all the sodium nitrite should dissolve. Once the solution is cooled down to 5 degrees C, set up an addition funnel to the top of the flask. Then add the nitrite solution to the funnel. Now, very slowly start adding this solution dropwise. It can be a pretty fast drop, just not a full stream. You want the solution to stay around 5 C for the entire addition. The sodium nitrite reacts with the sulfuric acid to form nitrous acid in situ. The nitrous acid then reacts with the aniline sulfate to form the diazonium salt. After all the nitrite solution has been added, you can remove the flask from the ice bath and let it stand to start warming to room temperature. As the diazonium salt begins to warm up, it will start to react with the water to form phenol and nitrogen gas. You'll be able to see this happening shortly after taking the flask out of the ice bath. After the flask reaches room temp, take the flask and place it in a large beaker or bowl and then add water around it. Begin heating the large beaker of water very slowly, keeping a close eye on the evolution of nitrogen. As the flask warms, the amount of bubbles forming will increase. Warm it up too fast and you'll have a real problem on your hands. Think elephant toothpaste. The goal is to heat it to 50 to 55 degrees C for 30 minutes, and not to let it get warmer than 55 degrees C. If it does exceed 55 degrees C, a tar material will start to form and your yield will go way down. As the reaction proceeds, more gas will evolve and the solution will start to darken in color. This is expected. After 30 minutes of heating, you'll probably notice the amount of bubbles has gone down to almost nothing. Pull the flask out of the hot water and set it aside to cool down slightly. Now set up for steam distillation. I just use a retort with a rubber hose on the end leading to a gas rod through a rubber stopper. The glass rod reaches the bottom of a 2-neck round bottom flask. Everything else is just like a simple distillation. Start the distillation by bringing your water to a boil and cooling your condenser. The goal is to steam distill 500 milliliters of distillate. This took me about an hour and a half to get. Oh, and a quick cleanup note. The black tar-like material that sticks to everything in the reaction flask cleans up easily with a concentrated solution of water and sodium hydroxide. While we're waiting for our product to distill, let's run a quick test. Later in this synthesis, we're going to use ether and evaporate it to dryness. We need to test our ether to be sure no peroxides have formed, or we'll be in for a really big surprise when distilling it later. Take a small test tube with a few crystals of potassium iodide inside, and then add a small amount of water. Shake the tube to dissolve the crystals. Now add a few milliliters of ether and shake. View the test tube against a white background and look for a pink color in the ether layer. If none appears like mine, then you're in good shape. If pink does appear, that means that your ether has peroxides in it, and they've reacted with the potassium iodide to form iodine. You will need to take steps to remove the peroxide before you can use it. One way is to shake the ether with sodium hydroxide and redistill. However, you should read up on peroxide removal if you find a positive result. Okay, since the ether is good, we can pull off our distillate and add it to a large SEP funnel along with 60 milliliters of ether. Now stopper the funnel, invert, vent, and then begin shaking, remembering to vent often. After about a minute of shaking, pull out the stopper and drain off the bottom aqueous layer. Take the top ether layer and pour it into a large bottle. It's helpful to use a large glass funnel when doing this. Now add the water back into the funnel and add a new 60 milliliters of ether and start shaking again. You're going to repeat this about 4 times. On my second extraction, I drained away a part of the water so you could see the 2 layers side by side. Notice the top ether layer has a deep golden tint to it. Here's my 4th and last extraction. Note that it has no color at all in the ether layer. The color is not phenol, but an impurity we get rid of later. However, this is a good example of how extractions work. Anyway, after you've added all the ether extractions to the bottle, place 5 grams of potassium carbonate to the bottle and then add a small stir bar and start stirring. Screw the cap on loosely to the bottle. This needs to stir for at least an hour. Alternatively, you can also shake it, but be sure to vent it if you do. After the ether is dried, decant it into a suitable round-bottom flask and distill the ether off. See my video on making ether for more information on how to do this. When nearly all the ether has boiled off, remove the condenser and set up for a short path to distillation by placing the vacuum takeoff directly to the still head. Now turn up the heat and discard everything till you get to 160 degrees C. Then stop, pull off the still head and the vacuum takeoff and clean them. Then replace and reheat. Keep the fraction boiling at 178 to 184 degrees Celsius. After distilling, place the distillate in a small beaker. If the phenol is liquid, you can get it to crystallize by scraping the side of the beaker, or do like me and use a seed crystal from a previous batch. After a few seconds, the crystals will form. Use a glass rod to break them up. Note that my batch is still contaminated with a yellow color, so I'm going to clean my distillation apparatus and redistill the phenol. I was much more careful on my second attempt and ended up with much cleaner crystals. Once again, I use a glass rod to break them up and then place them in an airtight container for storage. For this video, I was only able to make about 7 grams of phenol. My worst yield ever for this synthesis, probably due to my messing around with the camera instead of watching the reaction. On a good day, you can expect to get about 10 to 14 grams. Anyway, thanks for watching.